Now we will have the first example of mass-to-mass conversion. Example number 1. Calculate the mass of aluminum produced when 30 grams of Al2O3 decompose. The reaction is shown as. So this is the chemical reaction or equation. Now we already have a balanced chemical equation. From here, we can say, based on our previous lesson, that 2 moles of aluminum oxide will produce 4 moles of aluminum and 3 moles of oxygen. I repeat, the 2 moles of aluminum oxide will produce 4 moles of aluminum and 3 moles of oxygen. So having that, we can now start solving the problems. So again, we start with the given 30 grams of Al2O3. Now, we cannot use our mole ratio because our unit is still in grams. So, what do we need? Yes, we need the formula weight. So, let's get the formula weight or the molar mass of Al2O3. Alright? So, let's account. So, for aluminum, we have 2 atoms. For oxygen, we have 3 atoms in Al2O3. Now, you look at the atomic weight of aluminum from the periodic table. It's 27. And oxygen is 16. Alright, so this is times 27. And this is times 16. Okay, so just input in your calculator. So that would be 2 times 27 plus 3 times 16. Alright, so the answer is 102. So meaning the formula weight of aluminum oxide is 102 grams per mole. Alright, so since we have the formula mass, we're now ready to make that as our conversion factor. So what will you put in the denominator? Yes, 102. 102 grams of Al2O3 is to 1 mole of Al2O3. Alright, so we can cancel grams. Since our unit is already in moles, we can now input our mole ratio. So what will be our mole ratio? So let's identify the mole ratio we're going to use. Our required is aluminum. And our given is Al2O3. So meaning you have to get the mole ratio between aluminum and Al2O3. So in this case, the ratio is 2:4. So for every 2 moles of Al2O3, there will be 4 moles of Al. So let's put that. So 4 moles of Al, 4 moles of Al is to 2 moles of Al2O3. Alright, so mole Al2O3 also cancels. Now, are we done? Not yet. So, since we already have moles of Al, we can now get the mass by getting the atomic weight of Al. From our previous example, we know that Al's atomic weight is 27. So, Al is 27 grams per mole. However, you are not going to put it in the denominator anymore because if you put 27 grams here, it will not cancel. So you put 27 grams in the numerator and 1 mole of Al. So meaning for every 27 grams of aluminum, there's 1 mole of Al. Alright, so mole Al cancel. So is this our desired unit? Yes. So now you just encode in your calculator. So that would be 30 divided by 102 times 2 times 27, or 30 times 4 times 27 divided by 102 divided by 2. So in your calculator, you encode 30 times 4 times 27 divided by 102 divided by 2. Alright, so this is our answer. So our answer is 15.8823. 15.8823 grams of AL. Alright? So 15.8823. Now, let's express that in correct number of significant figures. So since we have 3 SF here, we should have 3 SF here. So that would be 15.9 grams of AL. So meaning 30 grams of aluminum oxide will produce 15.9 grams of aluminum. So that is your mass to mass conversion.